In this video, we're going to learn how to simplify rational exponents. And the form for that, if we have a base a raised to a fractional exponent a over b, that is equivalent to, keep in mind that b is going to be the root, okay? So b is going to be the root, and the a is going to be the exponent. And why do I mention that? Because when you have something raised to a fractional exponent, okay, the base goes inside the radical. We're taking the root, okay? What kind of root are we taking? Well, the denominator of that fraction is going to tell you that, okay? And then we're going to take that and raise that to the exponent a, okay? So what we can do is we evaluate the root and then raise it to the exponent. So an example of that would be, let's say you had 25 raised to the 1/2 power. That's equivalent to, again, the base, okay, this is the base. So that's what I'm referring to. Okay, and we're going to take that and we're going to raise that to 1/2 exponent, okay? So the denominator 2 is the root, and then the 1 is going to be the exponent. So how do we evaluate that? Well, evaluate what's in the parentheses first. What is the square root of 25? When we take the square root of something, we normally don't write the index of 2, okay? It's understood. The only time we write the index is when the root is greater than 2, okay? Like cube root, fourth root, fifth root. Then we have to indicate specifically when what the index has to be. So in this case, it's going to be 2. So I'm only writing it so you can see where it belongs. We take the square root of 2, we all know that that's going to be 5, because 5 times 5 gives me 25. And then that is going to be raised to the first power. And then anything raised to the first power is just that base right back, okay? So the answer is 5, okay? And anytime you have something raised to a fractional exponent where the numerator is 1, like 1/2, 1/3, 1/4, 1/5, etc., etc. Okay, that is also equivalent to this. Okay, so let's say you had, again, the fractional exponent is 1 over something. Okay, n could be any number, right? Could be 2, could be 3. That is equivalent to, okay, excuse me. Oops, my marker wasn't working. All right, that's equivalent to a to the n power equals b. In other words, what's that saying is that we're really asking what number, in this case, is going to be a, right? So, you know, what number, okay? Did we raise to the n to get b? Okay, so you know, when we think about that, all right, if we think about that, we can just say, okay, going back to the 25, right? We use the same example, 25 to the 1/2 power. Okay, we can say what number raised to the second power is going to equal 25. Okay, Well, the only number raised to the second power to give me 25 has to be 5. 5 to the second power has to be 5. Okay? But it's easier if you evaluate it the way I showed you before, because you can just convert it into the form, okay, and then just take the root and then raise it to the first power. Okay, but it is equivalent. You can do it this way as well as an alternative. So if you see it like that, it's really the same thing. Okay, so let's do some examples on the next slide. All right, and let's say you had 32 to the 1/5 power. All right. And when we do that, okay, we're going to write it into the form. Okay, remember, this is the base. Okay, the base is 32. The base goes inside the radical, the radicand. All right. And the denominator 5 is the index, so that should be going over here. And then this whole thing is going to be raised to the first power. Okay? So when we evaluate that, we take the 5th root of 32. What does that mean? That means what number multiply itself 5 times to give me 32. Okay? And it has to be 2. Because 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So it is in fact 2. Okay? And that's raised to the first power. Anything raised to the first power is just that base right back. And then you're done with the problem. Okay? So if you want to do it the other way that I showed you, then you can say, okay, what number raised to the 5th power equals 32? Then you have to think, okay, what number multiplied itself 5 times give me 32? Well, it has to be 2. Okay? So it's really the equivalency of that. So we know it's going to be 2 to the 5th power. That's going to equal 32. All right? But I just have a preference of writing it, you know, the 5th root of 32. That tells me I need to take the 5th root of 32. All right? And even if you had a calculator, you can do it. Take 32, hit the 5th root, and you should get 2. Raise that to the first power. Well, anything to the first power is just going to give me that same power back. So you don't even have to do that step. All right? Unless the exponent is different. Okay? So to make sure that we understand what we're doing here, okay, let's do another one. All right? So let's take, let's say we had 81 to the 1/4 power. All right, and I like to do it like this. I like to say, okay, the base goes inside the radicand. The index is 4, so the denominator is going to tell you what the index is, right? Or the root. Okay, and the exponent is going to be 1. Let me write it in red. Okay, so when we evaluate this, this clearly tells me that I need to take the 4th root of 81. All right, and the 4th root of 81 is in fact 3, because 3 times 3 is 9, times 3 is 27, times 3 more is going to be 81. So that is going to give me 80. That's going to give me 3. Again, it's still raised to the first power, but anything to the first power is just that base right back. Okay? If you want to do it the other way, you can say, okay, well, what number? That kind of looks like a... What number, okay, raised to the 4th power gives me 81. And then the answer would have to be 3. Okay? Because 3 to the 4th power will give me 81. All right? Okay. So, let's do another one. And we have negative 8 raised to the 1/3 power. Okay, so I like to do this. I like to write the radicand, and negative 8 is going to go inside. The index, the denominator tells me the index or the root, so it's going to be the third root or the cube root. And then my exponent is 1. So now I just evaluate what's in the parentheses first. Well, the cube root of negative 8 is going to be negative 2. Because negative 2 times negative 2 is positive 4, times negative 2 turns it into a negative 8. And you raise that to the first power. Again, anything to the first power is just that number right back. And there you have it. Okay? So that is kind of a way that I usually interpret that. Okay? Again, if you want to do it the other way, then you can say, okay, well, what number raised to the third power is going to give me negative 8? And then we're going to say, yep, it's going to be negative 2 raised to the third power. That's going to give me negative 8. Okay? All right. So pretty simple. All right? So you can do that with any, any rational exponent. But I have a couple more examples I want to show you. Okay? And what if we get this situation? All right? Now, I like this example because the negative is with the 4, right? Be very careful when you do something like this. Okay, we're still going to write the radicand. The question is, do I put the negative 4 under the radical, or do I put the negative outside of the radical? All right? So what we're going to do is we're going to do, actually, there's no parentheses around that negative 4. So technically that 4 is just going to be under the radical, and the negative needs to stay on the outside. Okay? And remember, when we do this, all right, keep in mind that the index is 2. And that's going to go over here. All right? I'm going to take, whoops, I'm so sorry. I didn't mean to do that. I'm going to write it in this color here. We're taking that, and then we're going to raise it to the first power. So again, this doesn't change the fact that the negative is outside the radical. So the square root of 4 is just going to be 2. Okay? And that negative stays where it is. All right, because it's not in the radical. We're not taking the square root of negative 4. We're taking the square root of 4. So the negative doesn't change. And that's still going to be raised to the first power. Okay? And anything raised to the first power is just going to be negative 2. So the answer is, in fact, negative 2. Now let me show you what happens when there are a set of parentheses. Okay? So let's say you had negative 81, and that's in parentheses raised to the 1/2 power. This is going to change the game a little bit. Okay? Since the negative 81 or the base is surrounded by parentheses, and that includes the negative, then we have to put that negative 81 under the radicand. Okay? And the index, which is 2, still goes there. And that whole thing is now being raised to the first power. And therefore, we're going to take the square root of negative 81. Now, what happens when you attempt to take the square root of a negative integer, okay, or any negative number? You're going to get an error message. Okay, it's undefined. You can't take the square root of a negative number. It's an imaginary number. It's a complex number. It's a whole different set of numbers. Okay? And this video is not going to discuss radical numbers, so it's going to be a little bit different. So if that happens, then this is going to be not a real, and you can also use the symbol real number. Okay, does that make sense? Okay, not a real number. All right, so we can't evaluate it. Okay. So in order to evaluate the square root of -1, you're going to have to factor the -1 out, and then that is called I, imaginary. So, and then you take the square root of 81, which would be 9, so the answer would be 9I. But that's not, we're not going to evaluate imaginary numbers here, okay? So that is not going to be able to be evaluated, all right? So my next example is, what if you get this? What if the fractional exponent is negative? Because not every exponent is going to be positive. You're going to have negative exponents, and that includes negative fractions, right? So remember that when you have this situation and you have a negative exponent, remember that's equivalent to 1 over 25 to the positive 1/2 exponent. You're probably saying, well, where are you getting that from? So as a little bit of a footnote off to the side, so let's say you had x raised to the negative ab power. That's equivalent to, okay, 1 over x to the positive ab power. I don't like the way that came out. Let me rewrite that. Okay, we do the reciprocal, 1 over x to the ab power. The exponent becomes positive. In simpler terms, let's say you had x to the negative a power. Well, that's equivalent to 1 over x to the a. You do the reciprocal, okay? X to the minus ab power is written over 1. So when you do the reciprocal, it becomes 1 over x to the ab power. Same thing here, x to the minus a over 1. When you do the reciprocal, it's 1 over x to the a power. So that's an exponent, rules of exponents, okay? Now, in order to evaluate the problem that we have over here, don't forget, 25 to the 1/2 power is really this, okay? 25, and then that's raised, right? That's taking the square root. Remember the rule, remember how we wrote that, okay? And when you do that, that's equivalent to 1 over the square root of 25 is 5 raised to the first power, and that's equal to 1 over 5. I'm just doing it step by step so you can see every single thing. That way there's no reservation of how I got the answer, okay? So 1/5 is going to be your final answer. Okay? I think we should do one more like that. 27 to the negative 1/3 power. That's going to be equal to 1 over 27 to the positive 1/3 power. You need to make that exponent positive. Okay? Okay, so let's go ahead and evaluate that. I was just checking something. I'm sorry if I paused there for a minute. So we're going to write that as 1 over, remember, the base 27 goes onto the radicand. The denominator is going to be the root, and that's going to be raised to the first power. Okay, so let's evaluate that. All right, so when we do that, okay, let me write it over here. It's going to be 1 over, what is the cube root of 27? What number multiplied itself 3 times to give me 27? Well, it's going to be 3, right? Because 3 times 3 times 3 is going to give me 9. 3 times 3 is 9. Times 3 is going to give me 27. All right? So the cube root of 27 is going to be 3. Don't forget, I'm raising that to the first power, right? And we said that anything raised to the first power is just that number right back. So the final answer is 1/3. Okay? Let's do one more over here. Negative 8 raised to the negative 1/3 power. So when we do that, that's going to be 1 over negative 8 to the positive 1/3 power. That's equivalent to, we write this as the square root of negative 8, and the index, the denominator is 3, so that means we're taking the cube root of that, and then you're going to raise that to the first power. So when you do that, what is the cube root of negative 8? Again, the number you should be thinking about is negative 2 times negative 2 times negative 2. That will give me negative 8. So the cube root of negative 8 is going to be negative 2. That's still raised to the first power. But when you evaluate it, anything to the first power is just that base number right back. So the answer is minus 1 over minus 2, or you can just write minus 1/2. That's how I'm going to write the final answer. You can just put the negative sign to the left of the fraction bar. All right, the overall fraction is going to be negative because a positive times a negative is an overall negative, so negative 1/2. Okay, I hope that you found this video to be very helpful, and thank you so much.